Morning, everyone. Thank you for joining us. And I wish you're staying safe. And I would like to wish you also happy Ramadan. And may God bless you all with this holy month. So I'd like to share a short story before we move towards our webinar today. So I've lived like most of my life in different African countries, and I heard this story. Like each morning, the gazelle would wake up and would think that he would have to outrun the fastest lion to stay alive. At the same time, same morning, a lion will wake up and will have the same thoughts that he will have to outrun the slowest gazelle or he will starve and die. So, regardless if you're a lion or a gazelle, whenever the sun comes up, you better be running. Welcome to our webinar. I'll introduce myself. I'm Ali El Kuntar, founder and CEO of Zero and One, and I will have Ali Habib joining me during the session for a demo. He's our CTO. We founded Zero and One and we'll introduce you in the next slide what we do before we jump in.
That's a qualified sales opportunity.
So,
basically, I'm trying to be, first and foremost, somehow it's kind of related also to the learnings that we collected here. So, first thing that, I know that we ran out of time, but I think it's super important. So, leads that are generated this way. So,
sorry guys, I just have to mute you. 1 second. Okay. Okay, guys. So, Zero and One, we believe that the innovation is to simplify complexity. Our values is we value customer obsession, where we work towards, we pay attention to our competitors, but we are always obsessed about our customers' output and we deliver results. We always we think long term and we don't sacrifice any short term wins. So we are always taking ownership. We are advocates of curiosity was framed, ignorance killed the cat. So learn and be curious, guys. Zero and One is a full life cycle cloud adoption partner. We are born in the cloud, all in AWS advanced partners. We deliver like with forward thinking approach, cloud native based thinking, and we will always approach helping your team to master the cloud. Why Zero and One? Because we are passionate, energetic, and very focused on AWS specifically. We don't have any other business born in the cloud, and we are highly skilled with 40 plus certificates among different specialties and professional services. So we've won several awards previously with AWS competitions. We offer a full-fledged services from cloud adoption to analytics, AI, cloud-native development. So our webinar today is about modern applications on AWS. So we will talk about modern applications and how AWS is helping customers transition to this new way of building software. We'll cover an overview of what we mean when we say modern applications and then zoom out to look at trends we are seeing in enterprise businesses. Then we'll deep dive on what Amazon has done to transform over the past several years and talk about what you can do to begin building modern applications. We will then wrap up with some of benefits of modern app and some live demo. So before we dive in, it's important to level set on what we mean by modern applications. So the good or maybe perhaps the bad news is that modern practices and modern applications refer to a point in time perspective. So what we are going to cover is based on what modern means today. In summary, it's how builders are leveraging people, process, and technology to build automated, operatable, business-focused solutions. A modern approach to software development is centered around 4 points. Shrinking the scope by leveraging different techniques to prove or disprove hypotheses quickly in a fast and safe way in search of customer value. So this is point number 1. Point number 2 would be offloading the undifferentiated pieces by seeking out ways to do less in order to do more. And the third point is choosing the right tool for the job, meaning to create more purpose-built solutions with less effort. And the last point would be automating everything for speed, consistency, and safety. So let's step back and look at trends we are seeing with enterprise customers. So we would like to talk about these key themes in terms of frequency spectrum. So on the left, you have low frequency enterprises where no change is the default state. Change is hard, risky, and takes a lot of time and effort. So versus the right side, where change is constant. So there is a flywheel of frequent value delivery. Ideas are considered hypotheses, and teams are closer to customers and generally more focused on customer value. So according to McKinsey, 90% of CEOs believe their industry will be digitally disrupted, but only 15% feel well positioned to execute on a high-frequency digital strategy. Similarly, from Gartner, 67% of leaders believe they need to move to a higher frequency model to remain competitive. On the flip side, we know that enterprises that have implemented high-frequency practices deliver value 46 times more frequently than traditional low-frequency enterprises. So there are typically a few historical reasons or experiences, let's put it this way, that have led enterprises to operate in a low-frequency environment. Sometimes it's because of failing or unstable applications that force IT teams to spend more and more time just to keep them running. Crisis or security compromise that has led to enterprises to become more cautious about making any changes for fear of creating a new exposure. And third point would be a big bet launch failure due to missed deadlines, budget overruns, and unrealized expectations, which ultimately diminish confidence in the organization's ability to deliver. So that said, there are 4 areas that we see enterprises also consistently focusing and iterating on to achieve escape velocity from their low-frequency environment. So technically, we are trying to, if we want to move from a high frequency, from low frequency to high frequency, there are 4 areas that we should be focusing on. So break up the work, which is number 1, which is moving from the monolith to microservices. Invest in your workforce and put them closer to your customers. Automate your bureaucracy to provide safety and speed. Build build it in, don't bolt it on, assuming attack and failures. So these 4 areas are very relevant to building modern applications, as the same techniques, practices, and technologies are required to achieve both high-frequency environments and to build modern applications. So let's look back at the history of Amazon. So back in 2001, Amazon had one monolithic application and one Oracle database. So it took 11 hours to update. 11 hours. Imagine Amazon is updating. It will take them 11 hours to update their code or their database changes. So consider this in the context of the dot-com boom. Amazon faced a serious challenge at that time in the market. So they came up with an idea. What if we increase the amount of ownership of each team, but decrease the scope of responsibility of teams? So increase the amount of ownership of each team, but decrease the scope of responsibility of teams. So this idea they called the concept of 2 pizza team, because the team should be small enough that it can be fed by 2 pizzas, typically 5 to 10 people in size. So these teams were long running, would own a specific set of functionality, and the teams were responsible for both developing and operating the service. Okay, so you see, so there is ownership and autonomy. And these changes were rooted in the idea of figuring out what is most important to your business. What's your North Star? So by thinking about where you want your business to be in 3 to 5 years. So at Amazon, they knew the time to market was their North Star. So they defined time to market. So they want to go fast. So then they made people decision, and then they made some technology decisions to support that. So it's people, it's culture, it's technology. More than a decade ago, Amazon took their monolithic code base and broke it apart into service-oriented architecture. They refactored the single code into small, focused, single-purpose services, which they called primitives. So for example, they had a primitive for displaying the buy button on a product page and one for calculating taxes. So every primitive was packaged as a standalone web service and had an HTTP interface. So the business logic and critically the data were only exposed to other teams through hardened APIs. So these building blocks only communicated to each other through the web service interface, so other teams could take advantage of existing services. So this created a highly decoupled architecture where these services could be iterated on independently as long as they adhere to their web services interface. So to give you like an idea of the scope of these small services, you can see this graphic on the right, right? So this is like a constellation of services that delivered the Amazon.com website in 2009. So and today there are tens of thousands of these across Amazon. So Amazon made the fundamental shift and their architecture in that there are no gatekeepers. So there is no line to wait for storage, compute, or database, or to start using machine learning. So in the old world, when you asked engineering teams how long it would take to get a server to try an experiment, I mean, they will tell you like 10 to 12 weeks. So with a defined North Star in the mindset, which is the go-to-market, time to market that Amazon already defined, so they set Amazon set out to reinvent this experience so they can increase the rate at which they could experiment. They thought others would benefit from this as well. And guess what? In 2006, we have AWS was born. So now in the cloud, you can provision thousands of servers within minutes, within 160 plus services, and that you can put together and use in whatever combination you want. So you get from an idea to implementation in several orders of magnitude really fast. So this concept of cloud, AWS, which was born from the Northern Star defined by Amazon, totally changes an organization. So increasing the amount of cycles employees spend thinking about innovation. So because they know if they have an idea, they have a chance to see if it works. So this expands the group of people inside a company that are thinking about new ideas from a select few to everyone. So instead of 11 hours of downtime to launch at Amazon.com, they now have over 60 million deployments a year. Guys, 60 million deployments per year. Okay, so when we talk about two pizza teams and culture, just remember that it has a practical application in the business. So this is just Amazon's story, but thousands of customers have embarked on this journey as well. So to achieve this model of agility, let's look at what changes need to be made and how AWS has helped many of these customers with those changes. Let's start with architectural patterns. So choosing the right pattern can help you shrink the scope of work and create focus for your application. So APIs should be the front door of your microservice. By providing this hardened contract, we can create a well-defined boundary between service consumers and our data and business logic. So let's consider how Amazon build APIs. So the first thing anyone at Amazon does when they want to build a new API is check to see if the API already exists. If it does, great, we use it. So if it's not, so then the team will write up an API description to submit to central API team, which they call the API bar raisers. So if it passes the muster, the team is allowed to go off and build it. Lots of microservices, Amazon customers even use this process as well. So this creates a catalog of your microservices and provide an organized way, transparent view of all your microservices. So without it, you risk duplication of APIs, unauthoritative sources, and lack of transparency into what exists. So let's look at the comparison of microservices to monolith. With a monolith, you have a large single system that does everything. So your application, you have one application that will do everything. On the other hand, with microservices, the impact of change is smaller. So release velocity can increase. So these smaller, finer grained architectures do one thing and do it well. And through what we call componentization, we get small, easy, identifiable pieces with well-defined interfaces. So this allows us to create cohesive systems made up of many small parts working together. When we pair these finer grained microservices with event-driven architectures, we can further simplify the components of the system. When you think about where or how to start building APIs, a question we often get is, it typically makes sense to start by identifying events in your system, because events are a good indication of where your services can be interconnected and therefore decoupled. So in the simplest terms, an event is a signal that a system's state has changed. In most modern systems, these are represented as JSON messages that provide some set of facts about what changed and potentially what the current state of the system is. So one of the key distinguishing features of events compared to commands is that events are observable, not directed. So in a command model, which we can see on the screen now, each command is explicitly issued to a specific recipient. Events, on the other side, are merely observable okay. Sorry, I think something. Okay. So, on the other hand, I mean, the events are observable by other systems. So here, a customer just ordered a widget. One of his coworkers is adding it to the sales report. Another decides to send an invoice, and several others aren't even listening at all. So what's nice about this, that it means that the event producers don't need to have any knowledge about who's listening to those events. So this keeps them simple and allows other services to consume events without needing the upstream system to change. So the benefit of event-driven architectures is that it allows you to shrink the scope of work by breaking it up into smaller pieces. So this allows us to distribute the work while decreasing waste, so we can focus on value by no longer having to coordinate all the listeners and manage all the downstream tasks. So systems become simpler and more focused. As your architecture patterns change, your operational model needs also to change. So the goal is to offload the undifferentiated pieces, so each team is more focused on delivering business value. So the first question that often comes up is around complexity. Isn't it more complex to operate many, like tens or hundreds of services compared to a single monolith? As a broad, system, there is significantly more complexity, but if done right, for each service team, owning a small set of larger system simplifies operations, even though your larger system may be more complex. This is where services like AWS Cloud Map or AWS App Mesh become so important. So they allow service owners to focus on their services while providing interfaces and visibility into the broader system. So with the evolution of compute, there are options to further simplify your operations. Customers tell us containers are great, but managing the infrastructure is undifferentiated heavy lifting for them. Too much of their time is spent controlling infrastructure, and not enough time to spend on the code, the application, and the application architecture, which is where they want to focus. Serverless lets you write code and lets somebody else worry about the infrastructure. Guess who's that someone else? That's AWS. Serverless removes the undifferentiated heavy lifting, that is server operation, reducing your operational load. This allows you to focus on building applications and creating value for your customers, rather than the management and scaling of the infrastructure to support the application. As you likely know by now, AWS has a shared responsibility model with customers where AWS is responsible for certain aspects of the infrastructure or system, and there are parts that AWS customers must take responsibility for. So AWS will provide many options that allow you to choose the right amount of control and configurability. That said, as you move left to right, you can offload more and more of your responsibility to AWS. So for example, by using the fully managed DynamoDB, all you need to do is create tables, right? Put data in those tables and query the table. So there is no infrastructure to manage. Quality of service is built in. And there are a set of knobs and dials to configure the database to meet your system's needs. So one more example would be S3. So we can create buckets and easily store files without having to worry about data durability or managing the data lifecycle. Simply configure your bucket and begin using it. In general, I recommend starting on the right and moving to the left only after proving you require more control. So because your goal should be to do less so you can do more. As you see on the right, all that a customer has to manage with AWS Lambda is application code. So this means you can innovate more, innovate quickly and more frequently. So, and deliver value more often by doing less. So from speaking, to a lot of customers, there is a common question, which is like, what is more appropriate for my workload? AWS Lambda or AWS Fargate? So, I wish this answer was more straightforward, but however, let's look into differences between them. So with Lambda, developers write code in units. Those units are called functions, and they define triggers to run the code. So Lambda starts, stops, and scales automatically based on the usage load it receives and the scaling throughput parameters you define. So you never have to worry about provisioning, scaling, patching, or managing the underlying service. And AWS will take care of it. Lambda is a great choice for applications that don't have specific infrastructure and requirements. It's because of its event-driven nature. AWS Lambda is great for data-driven applications that need to respond in real time to changes in data, shifts in system state, or actions by users for use cases such as batch processing, stream analytics, machine learning, and inferences. So with Fargate, you can run containers without having to manage servers or clusters. So you no longer have to provision, configure, scale clusters or virtual machines to run. So from my experience, if you have like any process that needs less than 50 minutes, go with Lambda. If you need any process that's bigger than 50 minutes long running, go with Fargate. So speaking of the right tool for the right job, right? So let's talk about how this new architecture impacts your database and data management. So if you think about each of these chips as microservices and the mothership as their database, so you can see how this common dependency, right? This monolithic database could hold back the broader fleet. So if we think about it in terms of Star Wars, so think about how one good hit blew up the Death Star. So there's better way to design your microservices. If you design your microservices like Amazon did, where business logic and data management is hidden behind a hardened API, you can more easily change, manage, and scale your data and services independently. So this also allows you to create more purpose-built solutions while spending less time fitting your data into, for example, a relational database, when what you really need is a time series database. So there is a saying that I really love, when discussing with customers, when the only tool you have is a hammer, so all problems are nails. So don't see, we have different tools when we are utilizing AWS. Let's look into problems based on the corresponding tools. So there's a family of purpose-built databases. While we are not going to dive deep on AWS databases today, but I just want to quickly share like the breadth of purpose-built database that AWS offer. So beyond relational databases to allow you select the right tool for the job. So let's talk about how to pizza teams and microservices. So we already defined a two pizza team, we defined microservices. How would they together change how you automate and how the cloud provides new opportunities for automation and guardrails? So let's start, with the release process. In the old monolithic model, you might have something that looks like this. So this was certainly the case for Amazon, where they had a big team of developers stepping on each other as they made changes in a big monolithic app, having to batch up and coordinate testing and releasing, causing changes to be deployed to production slowly and infrequently. So as you try to remove bottlenecks in the process and decompose for agility, you break up your big functional organization into smaller, the two pizza teams. As you introduce microservices owned by these teams, you have now removed bottlenecks in the developing the solution, but not testing and releasing. So in a product-based delivery environment, self-service tools and automation enables these DevOps teams to own and manage their own release process, creating ownership from idea to operation and back. So I think you can see how teams would be able to move much more quickly in this type of environment compared to the first one. So now that you have smaller teams focused on a smaller scope via microservices, we have a simplified environment. Through automation, we can build and automate securely, and you can implement, automate security and making the development team a part of your security team. So we can then provide security of the pipeline as well as security in the pipeline with things like artifact validation and static code analysis. So, and with open source tools like Cloud Custodian, we can provide built-in, constantly reinforcing guardrails that allows them to move quickly while following the rules you define. When we say guardrails, we always think highways. If you think about it, highways have defined speed limits, marked lanes, rules for passing on-ramps and exits, and the curves in the road were designed for travel at higher speeds. With these rules, we're able to travel faster and move freely at any time of the day, on and off the highway, as we see it fit. So each car has autonomy in their movement and decision making. But think about how frustrating toll booths, the toll booths are when you are cruising along at 65 miles per hour and have to then slow down and stop and wait in the line to pay. So gates have a similar but often more disruptive effect on our software development process and flow. So modern applications have automated guardrails in place, allowing for the removal of gates resulting in increased speed, autonomy, and agility. So while all of this may sound great, you may be asking yourself, how do I take my existing applications and turn them into modern applications? So let's explore the journey. I mean, most customers don't start off migrating modern and mature cloud applications. I mean, we tend to migrate what we have and make improvement along the way to a truly optimized workload. So, and when eventually leverage serverless and fully managed services. So you will start from shifting from your on-prem application using lift and shift, and then you start to optimize, and then you keep moving, and then you re-architect towards achieving the true maturity and optimized setup. So we tend to start migrating what we have to EC2 or to a container service using AWS AKS, AWS ECS, or AWS Fargate. So while each is a good starting point, modernizing the architecture moves us up and to the right. And not surprisingly, AWS Lambda is in the top right because it helps us shrink the scope and take an event-driven approach while offloading operation to AWS. So, while we may prefer to flip a switch, I mean, the reality is that moving from monolith to microservices is a journey. So just like modernization and maturity, they don't happen overnight. I mean, the good news is that there are patterns, used by many enterprises, which we can follow like as best practices and recommendations, maybe to simplify the transition. So in 2004, Martin Fowler, is a well-known speaker for development and had written a lot of refactoring good books. So he wrote about visiting Australia with his wife and spending some time in the rainforest in Queensland, of course. So one of the natural wonders of the area are the huge strangler figs. If you Google strangler figs, you will see the pictures of those. So they seed in the upper branches of a tree and gradually work their way down the tree until they root in the soil. So over many years, they grow into fantastic and beautiful shapes. So meanwhile, strangling and killing the tree that was their host. So he went on to use this metaphor to define a pattern for slowly killing your old application that requires a rewrite. So by intercepting events, as we discussed, and standing up APIs to replace the functionality responding to the event, you can remove functionality over time and eventually arrives at a place where the monolith no longer exists. It's a useful pattern. So let's discuss how 0 and 1, walked one customer through a journey towards modernization. Zone Voice is a telecom provider. They have their own application. They have 400 interconnections, carriers. They 6 million minutes per day, 50 million call record, and 3,000 call per second. So they were doing good, but with the changes that happened over the year, you can see they were having some real growth in the number of minutes and the total number of calls, but recently they are almost at a low growth rate because of the over-the-top applications, and telecom business is facing a lot of a competitive market now. So they see that one of the things, in order to survive, they have to lower their operational costs, and they have invested in some hardware back then, and they are facing problem in evolving and keeping up. So the trend of calls, their system normally will collect what we call call data records from their telecom switches, and will process these and rate them and feed the system. So the trend is like during weekdays the calls go down, during weekends you have peaks, you can see these peaks. But this is, let's say, December. So during holidays you will have unexpected peaks. So, and that's when the system would be slow and it is not very responsive. So they were at different levels of risks. So from operational risks, they have shifted live view of the calls because the processing was slow and the queuing was increasing. So they have a shifted live. So this is operational risk. Then they were at a financial risk because some customers has credit limits, and if you are doing a lot of calls with this delay, you might cross your limit and never been notified, or the team will be alerted late, and that was accounting for 500K of dollars per year as loss, potential loss. So, and from revenue perspective, they were they have a fraud detection system, and also due to the peaks and high demand during the holidays, they were not able to detect this right on time. So this would be a risk of losing $2.2 million according to their speculations. So operational risk, financial risk, revenue risk. So the thing is, this was they have one monolithic Java application collecting the CDRs live from their switches. They pull them, they parse these CDRs, normalize them, rating, and then they would insert to the database where they have the fraud management system, live review, credit limit, alerts, reporting. So all of this was a huge monolithic Java application doing all these processes. So when we reviewed after our discussions with the customer, understanding the problem, stating the cases. So we come up with, this is a part of the whole architecture, but this is what we are trying to show you guys, like how you can build a modern application utilizing AWS. So what we did is we utilized they were sending their streaming of CDRs to their FTP servers. So we integrated that with Kinesis producer library to stream these CDRs to Kinesis data streams and for ingestion phase. And then from ingestion, we used Kinesis data firehose to transform. We triggered Lambda functions to do the whole transformation and normalization, and it was near real time. So instead of having full waiting for like 5 minutes files, we were streaming the logs in batches, and so we can have faster views. And then after this was the breaking, the innovative part was introducing Kinesis Analytics, where you can do the rating on the fly, and then we are running live queries and defining credit limits and sending notifications on the fly. So this was like a really modernized way of approaching re-architecting and refactoring what ZoneVoice had. And then the live view was from a Kinesis stream, and we had on parallel, like this is another service, the rates were coming in regular manner through emails from different carriers all the time. So any rate would change and the effect might be immediate. So if you don't update the rating, then this would be incurring some loss for the company. So what happened is, like, we created some CloudWatch event-based trigger, which will trigger step function each minute, and minute of 5 it's configurable. So what happens, the step function is a state machine where it goes, it will fetch for a new email. If you have a new email, it will parse the attachment in another task. Once it's finished, it will normalize the output. Once it's finished, it will go and save them in the RDS relational database, where the updated rates will be found. So you can see, guys, from an architecture perspective, this is fully serverless deployment, event driven, and you can, I mean, it's really interesting how the performance that Zomvoice achieved. I mean, the risks that we were able to mitigate by having, without having to incur like renewal services for infrastructure. So now I would leave the floor for our CTO, Ali, who still have, I think we have 12 minutes left for an event-driven demo style.
Hello, thank you, Ali. Let me share my screen. Okay, currently we're going to work for.
Yes.
Can you see my screen?
Yes, sure.
Okay, perfect. Okay, so our demo today is going to be about adding subtitles to a video using event-driven and serverless technology. So we don't have any kind of compute power. We're just going to upload a video and walk through events to extract the audio out of this video, then translate this. Transcript this audio to text file, and then after that do some translation on this text, and later on add it to the video as subtitles. So this is the interface we're going to use. Let me walk you through before doing the demo on some of the on how it's done. So first thing, we're going to upload a video. It's going to go to an S3 bucket. After going to an S3 bucket, it's going to have an event. This event is going to trigger a lambda. After it's trigger a lambda, this lambda will run. Let's see here. This is the lambda start. So it's going to go for this lambda. I'm trying to be fast because we don't have time. And this lambda is going to start a step function. The main idea of step functions is like a state, but in serverless, because in serverless we don't have any state. It's going to start and stop. So step functions do solve this problem for us. In this step function, when we do start it, it's going to be this this step function. Let's see the definition of it. So this is what's going to happen. First, it's going to transcode. By saying it's going to transcode, that means it's going to call a lambda function. That's called sub lambda function transcode. It's also here, not this one. It's also here. So everything is serverless. So that's it. Sorry, no, transcode. Where is it? That one. Okay, so let's not waste time. Okay, so first thing, we're going to transcode, wait for the transcoding to be done to extract the audio from the video. Then we're going to transcript, get this file, and then wait for it to be done. After it's done, we're going to translate to multiple languages, as we can choose multiple languages. And after it's done, this function will update a DynamoDB at each state. In fact, at each state from these, it's going to update a DynamoDB table about the current status. And when it's done, we can immediately play the video. So I'm going to go and do some upload. Sorry, my mistake. I didn't choose the file yet. Okay. So I'm going to choose a short one so that, okay, and to choose some languages. Let's choose and French, and we're going to. Now, after the upload is done, it's going to kick in this Lambda. You can April 26. Still, it didn't. This will take some time to upload the. Okay, still also check the Dynamo. Okay. Subtitle. Okay, it's still uploading. It's after done uploading. We should have it here. Okay, as you can see, it came to the first Lambda and it did start, and this is live. Now it's working, and now you can see from transcode. We are waiting a little bit, and then we transcript. And at the same time here, what's going right now, and we can check the log from each Lambda that has run. So now we have to wait. If we go to the Dynamo, we should have a record. Yes, that's one. That one. It was created. This is my file, and now we're in the transcoded state. So here also, here we have it. We received the first the original file. Now we are at this level, transcoded. So it's going to take like 3 minutes, I think. All of it. Okay, we're done. Now we are in transcript. Let's see. It's done. Okay, so it's done. Now transcripting. Same here. It's going to be changed in the DynamoDB. And let's here, as you can see, you don't have any compute power. It's only these lambdas doing all of what we're talking about. If you can check the size of the it's negligible. It's very small. We're just using the power of AWS services to execute you to do translation. All of. Okay, we're done. I'm going to translate. So let's here. It will refresh in a while. It's translated. And it's done. Let's check on the step function. It says it's done. Succeeded. Let's go back here. Okay, so everything is done. Now we can play the video. Okay, and here I have to choose, for example, Arabic, because we chose Arabic. And also we can have French. I don't know if you hear the audio, but as you can see, using serverless technology, we were able to upload a normal video without any subtitles and then extract the audio, do some translation to predefined subtitles we chosen, and then after that, we were able directly to play this video with the subtitles we have chosen. Okay. So I tried, Ali, to be as fast as possible. We have 2 minutes left.
Thank you, Ali. So I would like to conclude with our building modern apps, because by changing their people, process, and technology, they can innovate faster and more frequently and bring those innovations to market faster, all while reducing costs and building more reliable applications. So we truly are witnessing a paradigm shift, and it's driven by our customers working backwards from what they need to do to win in the market. So businesses want to win more customers. To win customers, they need to build better products and to release features faster, which requires faster and more frequent experimentation and innovation. They need the ability to focus on differentiating business logic and to decouple software for speed and safety. So we no longer live in a world with a single database or architectural option. AWS is providing ways for customers to shrink the scope, offload the undifferentiated pieces, choose the right tool for the job, and automate everything. By doing so, you can build modern applications that allow you to win customers. I would like to thank you all. So, if you have any questions, those are our contacts. You may contact us for any request and requirement questions regarding building modern apps, DevOps on AWS, we are more than happy to support you. So if there is any question, I don't know if we have like 2 minutes. Junaid?
Yes, Ali.
Yes, we are done. I mean, if there is any question, we are ready for the audience. But
Sure. I think you've already provided your
Sorry?
I think you've already provided your contact details. So if there are any questions, then they'll write back to you. Yeah.
Okay, great. Okay. Thank you all. Thank you.
Thank you. Thank you,
Have
Ali.